Hello friends, welcome back. In this tutorial we will study about a tool called Lex. Lex is a lexical analyzer generator, right? This Lex tool, it is also called Lex compiler, right? So this Lex compiler is a lexical analyzer generator. So what happens if you are having this tool, Lex tool? You don't need to write a program to implement lexical analyzer. What you need to do, you need to simply specify the specifications of lexical analyzer, right? You simply need to write the specification of lexical analyzer in the program called Lex.L, right? This program Lex.L, right, which contains the specification of a lexical analyzer, it is taken as an input by the Lex compiler, right? And what happens, this Lex compiler gives lex.yy.c as an output, right? This lex.yy.c, it is a C program, right? It is given as a output by the Lex compiler, right? So if you are having this Lex tool, you don't need to write a program to implement the lexical analyzer, right? You just write a program called lex.l, and in that program you specify the specifications of lexical analyzer, right? And this lex.l will be taken as input by Lex compiler, and Lex compiler will give a C program as an output, and that C program will be lex.yy.c. And when this C program lex.yy.c runs on C compiler, right, it gives a.out as an output, and this a.out is an object program which is a lexical analyzer, and it transforms input stream into a sequence of tokens, right? So what happens when this C program, which is given as output by the Lex compiler, runs on C compiler, it gives a.out as output, right? And this a.output is an object program. It is a lexical analyzer, right? And it will transform input stream into a sequence of tokens. Now we will see the structure of Lex program, right? We will see the structure of that Lex program, which is taken as an input by the Lex compiler, right? The Lex program, it consists of three parts. First is declaration, right? And after enclosed in this double modulus symbol, right, there are transition rules, right? Second part consists of transition rules enclosed in double modulus symbols, and third part of the program is auxiliary procedures. So first part of Lex program is declaration. The declaration section includes declaration of variables, manifest, procedures, constants, and regular definitions. Now what are the transition rules of the Lex program? The transition rules of the Lex programs are the statements of this form: P1, and then in curly braces action 1, P2, then in curly braces action 2, so on, right? So what are these P1 and action 1? Here this P1, P2, P3 and so on up to Pn, they are regular expressions, right? And what are these action 1, action 2, action 3, right? These are the program fragment which are written in C, right? So what happens for here you can see P1, P2, P3, they all are the regular expressions, right? So if there is a regular expression Pi, right, then corresponding to this regular expression Pi, there is action I, right? You can see here for this regular expression P2, there is action 2 in curly braces. So what happens for a regular expression Pi, corresponding to it there is action I, right? And what is this action I? This is a program fragment written in C, and it describes what action the lexical analyzer should take when pattern Pi matches the lexeme, right? So here you can see corresponding to regular expression P3 in curly braces there is action 3. So what is this action 3? This action 3 is a program fragment, and it is written in C, and it describes what action the lexical analyzer should take when the pattern P3 matches the lexeme. Now the third section or third part of the Lex program holds whatever the auxiliary procedures are needed by the actions, right? The third part or third section of a Lex program holds whatever the auxiliary procedures are needed by the action.